Now that we know how to find the domains of certain functions and how to express those domains using intervals, let's look at a little bit of a new topic, the algebra of functions. We're going to learn how to create new functions from given functions. So what we're going to be given are two functions, f and g. And as usual, their domains would be capital D sub f and capital D sub g. If we're given them, then the new functions below are combinations of f and g. Very simple combinations. We're going to define them and we're going to find their domains as well. So let's define, this is a new function. This whole thing in parentheses, the f plus g, is a brand new function. If you wanted to, you could call it a new letter. You could say let h be the function equal to f plus g. But f plus g is very easy to define. F plus g of x is equal to f of x plus g of x, just like you would expect, I think. And now this one obviously is going to give you an f of x minus g of x. And this one, you could even put a dot in it if you wanted to, or a multiplication symbol, but putting two letters next to each other implies multiplying them. F times g of x is f of x, g of x, multiplied together. And the last one, f over g of x, is f of x over g of x. Now we need to discuss the domains of these functions. Remember, we know what the domain of f is. It's this. I mean, we don't literally know what it is, but this is the symbol that represents it, and this is the symbol that represents the domain of g. What do you think the domain would be of this function right here? Well, if I want to plug a particular value of x in here, I have to be able to plug x into f to compute this number, and I have to be able to compute x into g for this one. So the domain of this, I didn't give myself a lot of room, I'm going to put domain subscript f plus g is equal to, well, what numbers, remember your set theory, what numbers are in both of these sets? Because they have to, because this domain has to be numbers only that are in both of these sets. Remember, both in this one and in this one means intersection. So the domain would be the domain of f intersected with the domain of g. For example, if 0, one of these functions could be 1 over x, and you wouldn't be able to plug a 0 into that function. But you might be able to plug it into the other one. So if I were trying to plug a 0 in here, well, I'd be able to compute one of them, but not the other one. So therefore, that number, 0, would not be in the domain of this function. So this just says the domain of this function is all the numbers that you can plug in to both f and g. All of the numbers that are in the domain of f and also in the domain of g. Well, it'll be exactly the same for this. The domain of f minus g is the same. You have to be able to plug a particular number. In order to be in the domain, you have to be able to plug it into f and into g to come up with this number. So it'd be the same thing. Same thing. What about this? It's not the same thing. And I'm not even sure I want to write it down. I'll certainly explain it. It's close to this, but you might need to remove some numbers from it, because any number that makes g a 0, for example, if g of 5 is 0, 5 is not in the domain of this function. Okay, so any number that makes any x value that makes g of x equal to 0 is not in the domain. So maybe I will say the domain of f over g equals the domain of f intersected with a domain of g, but then I need to say something else here. And one way, I'll just put it in English. I'll say provided g of x is not equal to 0. And if it is, that means that x value has to be removed from this domain. And that's what we're saying right here. So I guess that took care of all of them for the domains. All right, let's take a look at number 5. And we're going to compute some new functions. We've got f of x is x minus 1. We've got g of x is x squared minus 1. And we're going to compute these functions. And I may not write down the domains, but we'll at least discuss them. So you could write them down. All right, well, here's f, here's g. What is f plus g of x? Well, f plus g of x is f of x plus g of x. F plus g of x is f of x plus g of x. That's the definition. I haven't done any work yet except write down the definition. And I think I'm going to go left to right. I'm going to go all the way along here. What is that equal to? It's equal to x minus 1 plus x squared minus 1. And that gives us x squared. I'm going to write this in the nice form. When we write polynomials, we usually go in descending orders of the exponents. X squared plus x minus 2. That's it. So this is equal to that. And by the way, since there is no fraction, no division, you can't have a division by 0, and there's no radical. The domain of f and g, all real numbers. And the domain of this one, all real numbers. Okay, f minus g of x is equal to f of x minus g of x. That's going to be x minus 1 minus x squared minus 1. Why am I pausing? Because I want you to find my mistake. Well, what did I leave out? It's f of x minus g of x, minus that whole function. So I have to put parentheses around g of x. I would have got one of those signs incorrect and I would have got the wrong answer. So make sure you put parentheses around this right function because there's a minus sign in front of it. So this would be, let's see if we can do this in our heads. The x squared, is it positive or negative? It's going to be negative. Then we've got an x that's positive. And then what about the 2? It's not 2. This is a negative 1. This is a minus 1. But when you distribute the negative sign, it goes negative x squared plus 1. So this is really a plus 1 and a minus 1. So it goes to 0. So here is the second function. Okay, the third one is fg of x, which is f of x times g of x, which will be x minus 1 times x squared minus 1. Well, this just requires foiling it out. So f first would be x times x squared, which is x to the third. Outer is a negative x. Actually, I'm going to do inner first, and I think we can get this written in the correct form. I'm going to do FIOL. Inner would give me a minus x squared. Outer gives me a minus x. And then last gives me a plus 1. Great, there's nothing, I don't have to combine any like terms because they're all unlike terms. So fg of x is equal to this. All right, now, last one. F over g of x is equal to f of x over g of x. Well, that's equal to f of x minus 1 on top, x squared minus 1 on the bottom. And that's correct, but it's not simplified. We should simplify that. Why isn't it simplified? Because what is that bottom? The bottom is the difference of two perfect squares, x squared minus 1. So that's x plus 1, x minus 1. So I get on top x minus 1 over x minus 1, x plus 1. So the x minus 1's cancel, simplifying, simplifying this to 1 over x plus 1. Now, I do want to make a comment about the domain, and I'm not going to, this last one might be a little tricky. The first three, the domains of these three functions, look at them, they're polynomials, all real numbers. The domain is all real numbers. The domain is all real numbers. The domain is all real numbers. This one is different, really different. You will be tempted to say that the domain of f over g is all real numbers except for -1, right? Because -1 would give you a 0 in the denominator. I purposely left the braces off here. You'll see why in a minute. When you're looking for the domain of a function, you don't simplify it first and then look for the domain. This is what you look at before you simplify it. This is what you look for the domain. This denominator is x plus 1, x minus 1, x plus 1. So you could get a 0 with either a +1 or a -1. So, therefore, the domain of this function, you don't simplify it before you compute the domain. So we go back to this. So the domain is actually all reals except for plus or minus 1. Okay? All right. Let's do a different kind of example. This one, f and g, both have radicals in them. So here are two functions. First, let's find the domain of f and the domain of g. Well, we already learned how to do this. The domain of f requires that I do this. Set what's underneath that radical greater than or equal to 0 and solve for x. So all that entails is adding 3 to both sides. Add the 3, so I get x greater than or equal to 3. Therefore, the domain of f is equal to the interval starting at 3 and everything greater, everything to the right on the number line. That was easy. Now g of x, I'm going to set everything underneath that radical greater than or equal to 0. And then I'm going to say I have to subtract 1 from both sides to get x by itself. So x has to be greater than or equal to -1. Which means the domain of g is the interval from -1 to infinity. Those are easy. Now, what is the domain of f minus g? I'll give you a hint. It's the same as the domain of f plus g and f times g. Let's see. How do we figure that out? Well, let me write down what f minus g is. F minus g of x is f of x minus g of x. Radical x minus 3 minus radical x plus 1. So what numbers could I plug into this function? Well, yeah, I have to be able to plug it into both of them, right? Suppose I put a number like, say, -1. Let's plug -1 in. If I plug in a -1 here, it works fine. It gives me a 0 under the radical. But if I plug in -1 here, it gives me a negative under the radical. So -1 is not part of the domain. How about 0? Could I plug in 0? I could certainly plug it into this one because it would give me a 1 under the radical. Could I plug a 0 in here? No, it leaves me with a -3 under the radical. So what numbers, without graphing these two intervals, what numbers are in both of these sets? -1 is not. -1 is not in this set. 0 is in this set, but it's not in this set. 1 is in this set, but it's not in this set. 2, even 2.9 is in this, but not in this one. The only numbers that are in both sets are exactly these numbers. If you were drawing the real line, and you did from -1 and then 3 would be, say, here. You can see that the only numbers that are in both intervals are not these ones, only from here on. So the domain of this function is simply going to be this. So the domain of f minus g, I'm just going to write this down, is the domain of f intersected with the domain of g, which happens to be equal to the domain of f. That's always the case when you intersect. This is actually d sub f right here. Whenever you have one of the sets completely contained inside the other one, the one that's contained inside it is the intersection. All right, let's look, to finish up this video, let's look at one more combination of functions called the composition of functions f with g. The composition of the function f with the function g. It's denoted like this. It's supposed to be just a round circle in the middle, this tiny circle. It's not a multiplication. Some people call this fog. They think of that as being the letter O. It certainly is not. This means f composed with g, and it's defined like this. F composed with g of x is f of g of x. Okay? F of g of x. So if you're going to plug in a number, say x is 0 and you want to plug in 0. Well, the first thing you have to do is the inside. You have to do g of 0 and compute that number. And say g of 0 is 5. Then you compute f of 5 to get the result that you're looking for. Okay, so based on what I just described, let's see if we can figure out the domain. The domain of f composed with g is the set of all x, all the real numbers, such that x, and I think we've seen this symbol before, if not, we're learning it now, is an element of the domain of g. It has to be in the domain of g, otherwise we couldn't plug it in here. Okay? But there's more to it. Then the number g of x has to be in the domain of this, or we wouldn't be able to compute it. So set of all x such that x is in the domain of g, and g of x is contained in the domain of f. And that's it. It's kind of a two-step process, just like computing this. Once again, if I plug in 0, g of 0, I plug 0 into g, so 0 has to be in the domain of g in order to allow me to do that. And then we get a new number out, and that number we plug into f better be in the domain of f. And we're plugging in the g of 0, or g of x in general. All right, so the last comment just is asking you what I just explained, basically. If x is not in the domain of g, then x is not in the domain of f composed with g, because if this x is not in the domain of g, you can't even plug it in there. You won't get a number out. If for some x, let's say g of x does exist, but say you can plug it in and get g of 0, like I said before. G of 0 gives you a new number, but if that number is not in the domain of f, you can't plug that number into f to get your new number out. So that's why x would not be in the domain of f composed with g. So that one takes some thinking about it, especially if this is the first time you've seen composition of functions.